Hello and welcome to the SkyWave GarminFMI API demonstration webinar. In this video, Amjad Farhan, Manager of Mobile Software Applications at SkyWave, will demonstrate a couple of examples on how to use the GarminFMI API IDP service provided by SkyWave to communicate with a Garmin device.
Hi, my name is Amjad Farhan. I'm the Manager of Mobile Software Applications at SkyWave. For questions on this video or on GarminFMI, please contact our customer support at support@skywave.com. I will first clarify the target audience for this video and the minimum requirements you need to have in order to replicate the demo described in this presentation. I will then give you a quick overview of GarminFMI API service. I will introduce you to the AS026 document, which describes the GarminFMI API. I will show you how we can write a simple text messaging application for IDP terminals using GarminFMI API. And finally, I will load this text messaging application on my terminal and show you how it works. The target audience for this video is Lua developers who are familiar with IDP terminals and their Lua Services Framework API, and finally developers who are familiar with SkyWave Developers Toolkit. The toolkit can be downloaded from the SkyWave support site, and the tools that I will be using in this video from the toolkit include Developer Studio and the Messenger tool. To replicate the demo in this video, you will need an IDP terminal or a desktop terminal. You will need an IDP development cable, IDP Garmin cable, FMI compatible Garmin device, power supply, Windows computer with SkyWave SDK installed on it, and GarminFMI service package file. So what is GarminFMI? FMI, or Fleet Management Interface, is a suite of proprietary Garmin protocols that allow third-party terminals like IDP terminals to communicate with an FMI-compatible Garmin device. Using these protocols allow the Garmin device, which is normally used for voice navigation, to be also used for other management tasks such as text messaging. The GarminFMI is a compiled Lua service for all IDP terminals. It has a unique service identification number, or SIN, of 125, and it can be enabled or disabled on demand. This service is part of a premium set of billable Lua services offered by SkyWave to help reduce development time for IDP applications. It basically provides a link between other Lua services you may develop on your own on IDP terminals and connected Garmin devices. Version 2.1 of the GarminFMI service supports the bulk of FMI version 2.7 features, including text messaging, quick messages with canned responses, stops, and estimated time of arrival, driver identification and statuses, speed limit alerts, and many more. Future versions of the GarminFMI service will support even more features of the FMI protocols as they become available. The interface, or API, for the GarminFMI is described in the accompanying document number AS026. The API consists mostly of Lua functions and events. Functions are used to send commands from an IDP terminal to the Garmin device connected to IDP, while events are used to broadcast notifications received from the Garmin device to other Lua services. The API also includes a number of service properties that provide dynamic information about the connected Garmin device, such as version number and connection state, and to enable some debug information on the IDP's trace output. So now let's write a simple demo user service in Lua to accomplish the following two objectives. First, we wanted to define and handle a toMobile message that would be used to send a text message from a back-end server application to a Garmin device connected to an IDP terminal. And then next, in the other direction, we want to define and handle a fromMobile message that would be used to send a text message from a Garmin device connected to an IDP terminal to the back-end server application. In this demo, I will be using SkyWave's Developer Studio tool, which is part of the IDP Developer Toolkit, to define the tool messages, to write the code, and compile the package. Let's create our project using the Developer Studio tool. Let's start with a simple project that has the minimal service. It's a template that is provided by the developer tool. And then let's give this project a name. And this project contains only one service, so let's give that also a meaningful name. And then let's define first the over-the-air messages. So we have two messages that we need to define, one in each direction. So the toMobile message, I'll give it a name, let's call it toGarmin text message, and the message identification number for that message, or min, is 1. And then let's define the fields that go into this message. In this case, it is only one field of type string that would contain the text message that we want to send to the Garmin device over satellite, and the maximum size of this message is 199 bytes. Then let's define the message in the other direction, so the from mobile message. Give that a name, let's call it from Garmin text message, and I'll give it a min of 1. And similarly, let's define a field for this message of type string, and that would contain the text that the driver or the user on Garmin would type to send over the air. So now let's start by actually writing the code that would handle these messages, and that code would use the GarminFMI API, which is described in AS026. So first, let's define a variable that would contain the message handle for the messages that correspond to this user service. Now let's assign a value to this variable by registering our service for messages that target this service. Next, let's validate that the GarminFMI service is actually loaded and enabled on our terminal before we proceed in using it. Next, let's first handle the received messages over the air, so toMobile messages. And to do that, as shown in many other examples that we have, we need to create an event queue that handles an event called rx_decoded, and this event is documented in the T202 document. So we created an event queue that waits for this event to occur and captures it when that happens. Now in our document, the AS026, the first thing we need to do before we use the Garmin devices, we need to call the Garmin Connect function. So if we just copy and paste that into our code, and then we need to populate some parameters for that function. It's called the FMI enable table. So this is also described in the AS026 document. So these are the variables for the table, so we'll just select them. Most of them are not relevant to this service, and most of them I think are assumed to be false if they're missing. So we'll just pick some values here. We don't care about driver passwords and multiple drivers and so on. So after that, we will start our infinite loop in our main thread. And in our loop, we will wait for the events that we're interested in for them to happen. And we do that by invoking the sched.waitQueue function. And we'll make sure that in the waitQueue function, we're waiting indefinitely for the event queues that contain the events that we're interested in. Currently we have only one event queue, so it's called the MSG queue. So the waitQueue function will block our thread until we get an event, and when that happens, we will check the type of queue that unblocked the waitQueue, And in this case, we have only one queue, but we will check it anyway. So it is the message queue. And if that is the case, we'll also confirm that it is of min1. So this message queue indicates that a to-mobile message has been received by IDP. And if it is min1, then it is our message that we have defined, which means that someone wants to send a text message to the Garmin device. Before we go ahead and call the function that would send this message, let's check to make sure that, first of all, Garmin is in the ready state. So that's just simply reading a property on the GarminFMI service. So if it is in a ready state, then we should be able to go ahead and send that text message to Garmin. So if we go and look up for that message that we need to send, to call in order to send a text message to Garmin, it would be listed under the functions, under the text messaging section, and it is an open text message. So this is the format of the function that we need to use. So if we copy and paste that function and update the parameters for that function. The most important parameter is, of course, the content, the text, and this is going to come from the message that we just received. And the second parameter indicates that it is a full screen. We want this message to appear on the Garmin screen in full screen. However, if the GarminFMI is not connected, then we want to send an error message back to the user over the air to indicate that we could not deliver this text message to Garmin. So that handles one side of the communication with Garmin, so the to-mobile side. So let's now handle the other side. So if a user types in a text message on Garmin and wants to send that over the air. So for that, we need to capture a different event that comes from the GarminFMI service. So we'll create an event queue called Garmin queue. Event that we're interested in. So under events in the document, there's an event called open text received, and it has a table of arguments. And in that arguments, we have the field text MSG, which would contain the text message that was typed by the user. So if we create our event queue and call it Garmin queue and add it to the list of queues that we're waiting for them to report an event, and then in our big if condition here, we will add another block to check to see if the event queue that unblocked our wait queue function is the Garmin queue. And if that is the case, we want to do two things. We want to acknowledge receiving this text message from Garmin. So we do that by calling a function in the GarminFMI service. And that function is documented in the AS026, and it's called GarminFMI text underscore send receipt. And of course, we need to supply a unique message ID for that message that we just received from Garmin, and also supplied to us via the arguments of the Garmin event. The next step is we want to send this message over the air. So to do that, we'll use our message handle function called the send method on our message handle and populate the fields in our message. And we have only one field, which is the text. So we'll populate that with the argument that contains the text. And that's pretty much it for our code. And our project should be ready now, so let's save it. And then let's export this package. That's what we need to also make sure that is loaded on the IDP terminal. And finally, we want to export the message definition that is unique to this service according to how we defined our messages. Now to test this application that we just wrote, we need to export the package and load it on the IDP terminal that is connected to a Garmin device. Now, these steps that are mentioned here are also explained in more detail in our introduction video for Garmin. But basically, we need to open Solution Studio, which is part of the IDP Developers Toolkit tool, and then we need to add the GarminFMI package file and the Garmin Demo package file, and then we can load it using the console tool on the IDP terminal. In this example that I'm going to show you, this demo, I'm going to be using the modem simulator, so a simulated modem and a simulated gateway, to show you how we can send and receive text messages. And I'm loading this combined package of GarminFMI API and the Garmin Demo to a desktop terminal. My setup consists of a Garmin device connected to an IDP desktop terminal, which is connected to the modem simulator tool on my computer. I will also be using the messenger tool to send and receive simulated IDP messages to and from my IDP desktop terminal. Garmin will be shown on the right side of the screen, while the messenger tool will be shown on the left. So let's start our demo by sending a text message from Garmin. So let's go to Messages and compose a new open text message. So let's type hello from Garmin. And hit done, and then confirm that we want to send it. And now let's notice on the messenger side, or the server side of things, so in the outbox it's been submitted, and messenger we received it, and if we click on it we'll see the content of that message. It has one field, which is hello from Garmin. So now let's do the other direction. So let's send a message from messenger or from the server side of things to the desktop terminal. So we'll select the terminal, we'll select the service that we want to use, which is the Garmin Demo, or the text messaging, and then we'll select the message, and there's only one message that we defined in the to mobile direction, and that message has one field called text. We'll populate that field. Let's say hello from dispatch, for example, and hit send. And I can check the status of that message. It has been sent, and notice that we received this message on Garmin in full screen.
In this video, Amjad demonstrated how you can write a Lewis service application to send and receive text messages with Garmin over the air using the GarminFMI API service. We hope that this video will help you to develop applications that involve Garmin as a mobile data terminal to meet your customers' needs. If you want to learn more about the SkyWave GarminFMI solution, or if you have any sales-related questions, please contact your SkyWave sales representative. For technical questions, please email support@skywave.com. Thank you for watching.